it is very easy to build a POC, and then it targets a very specific and narrow set of real world scenarios, and it doesn't generalize well to other types of scenarios. And that's the biggest problem. Of course, there are security issues and all kinds of stability issues, even with the biggest labs and the biggest providers of LLMs, because those APIs are also not always stable, and you need to take care of that. But that's operational issue. I think the biggest issue is not operational; it's actually evaluation based and sometimes even use case based. Maybe the use case is not a correct one.
All right. So today, for our first episode of this podcast in 2026, we have Aurimas Griciūnas of SwirlAI, and he was previously at Neptune.ai. And so, welcome to the podcast, Aurimas.
Hi Ben, and thank you for having me on the podcast.
And so, actually, I want to start with a little bit of culture before we get into some technical things, right? So, I noticed. So now it seems like you're back to teaching people some of the latest ML and AI stuff, and of course, before the advent of generative AI, the terms we were using were ML engineer, ML ops. Now it seems like it's AI engineer and maybe LLMOps, right? So I'm assuming you use this terminology in your teaching and consulting as well. So in your mind, Aurimas, what are some of the biggest distinctions between that move from ML engineer to AI engineer, from ML ops to LLM ops? What are some of the key, let's say, 2 to 3 of the biggest things that people should understand?
Okay, so that's a great question, and the answer depends on how you define AI engineering, and I think how everyone today, most of the people today define it uh, is a discipline that builds systems on top of already existing large language models. Maybe some fine tuning, maybe some tinkering with the models, but it's not about the model training. It's about building systems on top of already the models that we already have. So the distinction is quite big because we are no longer training models; we are reusing models that we already have, and hence the discipline itself becomes a lot more similar to software engineering than actual machine learning engineering. So we are not training models; we are building on top of the models. But some of the similarities remain because both of the systems that we used to build as machine learning engineers, now build as AI engineers, are non-deterministic in their nature. So some evaluation and practices of how we would evaluate these systems remain. Um, so in general, I would even go as far as to say that there are more differences than similarities in these two disciplines, and it's really, really hard to probably distinguish 3 main ones, right? So I would say software engineering, right?
So I guess based on your description there, the personas have changed as well, right? So in the previous incarnation, you had ML teams, data science teams. They were mostly the ones responsible for
Yeah.
doing a lot of the building of the models. Now, as you point out, at most people are doing some sort of post training from fine tuning. Maybe the more advanced teams are doing some sort of RL, but that's really limited, right?
Yeah.
Um, so the persona has changed. But on the other hand, at some level, Aurimas, it's still a model. So then you still need a data scientist to interpret some of the metrics and the evals, correct?
Mm-hmm.
So, in other words, if you run with completely just here's a bunch of software engineers, they'll do everything.
Mm-hmm.
Uh, Obviously, you can do that. So, but is that something you recommend without having any ML expertise in the team?
Yes and no. A year ago, or 1 or 2 years ago, maybe 1.5 years ago, I would say that machine learning engineers were still the best fit for AI engineering roles because they were used to dealing with non-deterministic systems. So they knew how to evaluate something there, something that the output of which is a probabilistic function, right? So it is more of a mindset of working with these systems and the practices that come from actually building machine learning systems beforehand that were very useful to dealing with these systems. But nowadays, um, I think already many people, many specialists, many software engineers have already tried to upskill in this non-determinism and learn quite a lot of how you would evaluate these kinds of systems. And really a big value from, not a big value, but the most valuable specialists nowadays that can actually, I would say, bring the most value to the company that is building these kinds of systems is someone who can actually build end to end. So has all kinds of skills, starting from actually being able to figure out what kind of product to build, then actually implementing some POC of that product, shipping it, exposing it to the users, and being able to react on the feedback on the evals that they kind of build out for the system. But the eval part can be learned, right? So you should spend some time on it, but I wouldn't say that you need a dedicated data scientist or machine learning engineer specifically dealing with evals anymore. A few years ago, probably yes.
So uh, so based on what you're seeing, so people are beginning to organize accordingly. So in other words, the recognition here is that um, if you're going to build some of these modern AI systems or agentic systems, it's really not about the model. It's a systems and software engineering problem. So
Yes.
therefore, we need people who are of that mindset. But on the other hand, it is still data. It's still a data oriented system. So you might still have pipelines, right? So
Mm-hmm.
data
Yes.
pipelines that data teams and data engineers typically maintain. And uh, there's always been this lamentation, even before the rise of generative AI. Hey, these data pipelines maintained by data engineers are great, but they don't have the same software engineering rigor that the people building web applications are used to, right? So,
Mm-hmm.
what's your sense in terms of the rigor that these teams are bringing to the table in terms of software engineering practices?
So it depends who is building the system. If Because AI engineering and AI engineers are of extremely wide range. So
Wide
data
range, right? Yeah,
engineer
yeah.
can be an AI engineer, a software engineer can be an AI engineer, and machine learning engineer can be an AI engineer. So um,
I guess. Let me rephrase that, Aurimas. So, in your
mhm.
mind, so the best teams, what's kind of the typical staffing pattern?
Depends on the size of a project. If it's just a project that's starting out, then I would say full stack engineer can quickly actually start off a project, build a POC, and continue expanding it. And then there will be a
Mainly,
need to
mainly
bring,
relying on some sort of endpoint, API endpoint for the model.
not necessarily, right? So it can be a REST API based system, it can be a stream processing based system, it can be just a CLI script. I would never encourage to build a system which is more complex than it needs to be, because very oftenly when you have an idea, just to prove that it works, it's enough to build out a Excel spreadsheet with a column of inputs and outputs, and then just give the outputs to a stakeholder and see if it's useful. So it's not always needed to start with a REST API. um, but in general, when it comes to people, like who should start it off, I think it's people who are very generalist, because at the very beginning you need to understand end to end, right? So from product to software engineering to maintaining those systems. But once this system evolves in complexity, then very likely the next person you would be bringing on is, again, depending on the product, but very likely would be someone who is good on with data engineering, because as you mentioned before, most of the systems are relying on a very high, very strong integration with already existing data systems. If you're building for an enterprise, for example, and that's a hard thing to do right. And data engineers do it quite good, right? So definitely a very useful person to have in a team, and maybe eventually, once those the evals come into play, proper evals come into play, uh, depending on the complexity of product, the team might benefit from having an ML engineer or data scientist in the team. But then this is more uh, kind of targeting those cases where the product is as complex enough so that you actually need some LLMs as the judges, and then you need to evaluate those LLMs as the judges so that you know that your evals are evaluated as well. If you just need some simple evals, because some of them can be um, no exact evals, assertion based evals, those can easily be done, I think, by someone who doesn't have a machine learning experience in the past.
So another cultural question I have is the following, right? So I would say if 2 years ago, 18 months ago, most of these AI projects were conducted basically. It was a little more decentralized. In other words, right? So here's a group here. They're going to do something. They're going to build something on their own, and
Mhm.
uh, and then maybe try to deploy that. But now recently, I'm hearing Aurimas, and I don't know if you are hearing the same thing, that at least in some of these big companies, they're starting to have much more of a, or some sort of centralized team that can help other teams. So in other words,
Mhm.
there's a centralized team that somehow has the right experience and has built a few of these things, and then now they can uh, uh, kind of consolidate all those learnings, and then help other teams, and then so if, in other words, if I'm in one of these organizations, then I approach this kind of experts. I guess in the old days, I hate this term, but they would use some sort of center of excellence kind of thing, right?
Yes.
So and then you will get some sort of playbook, and they will uh, help you get going. Kind of, in many ways, sort of like in your previous incarnation at Neptune AI. It's almost like you had this centralized tool, an experiment tracker, where someone can go in and learn what others are doing, and then
Mhm.
and then learn from each other. Is this something that you're hearing, that people are going for more of this kind of centralized approach?
Um, I do hear about these kinds of situations, but it's always when, of course, naturally, it's always when it is an enterprise, a big enterprise, that
Yeah,
can
yeah, yeah,
actually
yeah.
manage to pull that off. And I believe that's the right approach, because that's also what we have been doing before GenAI, right? We had those centers of excellence, and
And,
I don't
and then
know.
I guess for our audience, explain why you think this is the right approach.
So two things why I think it is the right approach. So the first thing is that we used to have these platform teams that would
Exactly. Yeah.
build out a shared pool of software that can be reused by other teams. So we kind of define the standards of how these systems should be operated in production and in development, and they would decide what kind of technologies and tech stack should be used within the company. So I think it's a good idea to not spread too widely in the tools that you're using. Also have some template repositories that you can just pull and reuse, um, because then not only it is easier to kick off and start your build out of the project, but it also helps kind of control how well this knowledge can actually be centralized. Because if you're
And
using
also
everything,
there
then
the
you,
security and governance as well, right? So
for example, yeah, security
yeah,
and governance as well. Yeah.
yeah,
So platform side is one of those, right? So
yeah.
just use the same stack and help others build it easier and faster. And the second piece is that indeed GenAI is still very, or I would say, yeah, Gen AI systems are still very uh, young, right? So very early, and we really do not have, as some would say, enough reps in building these kinds of systems. So we learn as we go. With regular machine learning, we already had everything figured out. We just needed some practice. Now, if we learn in this distributed way, and then we do not centralize the learnings, then we suffer a lot. So basically that's why you would have a central team that holds the knowledge, but then it should help other teams implement some new uh, maybe a new type of system, and then bring those learnings back into this central core, and then spread those learnings back to other teams. But this is also how we used to operate in these platform teams in the old days, 3 years ago,
Exactly.
4 years.
Right, right. But then I guess uh, what happened with the release of generative AI is that the platform teams might have moved too slow for the rank and file. And so hence you started hearing about what they call shadow AI, right? So where people
Mm,
would use tools that were not exactly blessed by the platform team.
yeah.
But now I think the platform teams are starting to wrest some of that back, right?
I wonder if it is platform teams who are kind of catching up, or is it the tool stack which is maturing and the practices that are maturing? I think we are getting more and more reps in building those systems, and now it's easier to catch up with everything that's going on. Initially, it
So
wasn't.
so
I would even go as far as to say it was impossible to be on top of it, and maybe it wouldn't even make sense to have a central team.
So a lot of these demos look impressive, right? So generative AI demos, agents, but they fail when you deploy them in the wild. So in your mind, what is the single biggest hurdle or the most common reason why a lot of these demos or POCs uh, fall short or become unreliable in production?
That again depends on where we are deploying the system, but one of the main reasons is that it is very easy to build a POC, and then it targets a very specific and narrow set of real world scenarios, and we kind of believe that it solves
More
that,
than
but
it,
it doesn't.
more
Yeah,
than
but
that.
yeah, and it doesn't generalize well to other types of scenarios, and that's the biggest problem. Of course, there are security issues and all kinds of stability issues, even with the biggest labs and the biggest providers of LLMs, because those APIs are also not always stable, and you need to take care of that. But that's operational issue. I think the biggest issue is not operational; it's actually evaluation based and sometimes even use case based. Maybe the use case is not the correct one.
Before the advent of generative AI, ML teams and data teams were just starting to get going on observability, and then
Yeah.
obviously generative AI comes into the picture. So, what changes as far as LLMs and generative AI when it comes to observability?
I don't think that I don't believe that it is even this. I wouldn't even call it as the same thing, like observability of regular machine learning systems and Gen AI systems. Going back to previous parallel kind of generative AI observability is a lot more similar to regular software observability. It's all about tracing your application, and then on top of those traces that you collect from in the same way as you would collect from a regular software application, you add some additional metadata on top of it so that it is useful for performing some actions, some evaluation actions on your agentic AI type of system. So I wouldn't even contrast machine learning observability with Gen AI observability, because I think these are two separate things.
Yeah. Because the especially when it comes to agents and the agents that involve some sort of tool use, then you're really getting into kind of software traces and software observability at that point, right? So
Yeah, so exactly. Tool use is just a function call. A function call is just a regular software span, let's say. Now, what's important for GenAI is that you also know why that tool was selected to be used, and that's where you trace outputs of your LLMs, and you know why that LLM has that LLM call, that generation has decided to use this and not the other tool. So things like prompts, token counts, and how much time to first token it took for the generation. These kinds of things are what is additional to be traced compared to regular software tracing.
yeah, and then obviously there's also I guess one of the main changes probably this year will be multimodality. Maybe there's
Mhm.
different types of uh, modes and data
Yeah.
involved, right? So
So that's true. Like, okay, so I didn't for some reason I didn't touch upon that, but you're right. There's a lot of difference here because inputs and outputs. It's hard. First of all, it's harder to trace these kinds of things, like let's say audio input and output, video, images. But I think even harder kind of problem with this is how do you make sure that the data that you trace is useful? Because those observability systems that are being built out, like Langsmith, Langfuse, and all of the others, how do you make it so that it is convenient to actually look at the data that you trace, which is not text and not regular software spans? How you will even correlate two different audio inputs to each other? How do you do that? I don't think that problem is solved yet, and I don't even think that we know what we want to see when it comes to comparing this kind of data next to each other. As an example.
let's talk about agents. A friend of mine actually asked me yesterday. So Ben, are agents real, especially on the consumer side? And my friend was saying he doesn't think it's real. So I said actually it's more real than people think in the following sense, right? So first of all, deep research, that's agents, right? So
Mhm.
and then secondly, I said people might be using agents, uh, might be using applications that involve agents, but they don't know it, right? So for example, they're interacting with the system, and that system involves some sort of data pipeline that's being that was written and is being monitored and maintained by by an agent. But sure, the actual application is not an agent, but
Yeah.
underneath there's agents involved in the application. So to that extent, I think agents are they're definitely real in the data engineering and software engineering space, but I think there might be more consumer apps that underneath there's some agents involved that consumers don't know about. What's your sense?
Mm, for quite similar, I don't think there are real agents, full-fledged agents that are exposed to
Yeah.
consumers
I
that
think
are.
people when people think of agents, they think of it as like they're interacting with the agent directly, right? So,
Yeah.
and that may not be the case yet, right? So,
And then it depends on how you define the agent. Is it fully autonomous agent? What is an agent to you, right? So GenAI in general is very useful in many occasions. It doesn't necessarily need to be a tool using self-autonomous agent, right?
like I said, so the canonical example for consumers would be deep research. Those are
Deep,
agents.
those
So,
are agents, that's for
a-
sure. Um,
and so if you think of that example, right? So, what is that? So, it's a bunch of agents searching across different data collections and then maybe a central agent unifying and making and presenting it to the user in a coherent way. So from that perspective, there probably are agents powering consumer apps, but they may not be the actual interface of the consumer app, right? So the actual interface might still be rule based or something, right? So
True, like
yeah,
data processing, some automations happening in the background. And when you say deep research agent, that is exposed to the user, right? This is
yeah, yeah.
a
That
user-facing
that's exposed,
application.
right? Yeah, yeah.
Now that's that's relatively easy to build because you don't need to very strongly evaluate this kind of system, right? Because you expect the user to eventually evaluate the results. Did
Or
the agent actually provide good results?
or or in the case of Google, you can present both, right? So they have the AI summary, and then they still
Mhm.
have the search results. And then
Yeah,
based on the user signals of what the user is actually consuming, then they can continue to improve their deep research
yeah.
agent. Right?
So let's say the disasters that can happen from wrong results is not they were not that bad, right? So
Or
uh,
no, it can be bad if you deploy it inside the enterprise and you're using it to prepare your CFO for some earnings call, right?
true. But
Yeah, yeah,
then
yeah. So
whose responsibility is it? The agents
So
to
that
provide
would
100%
that would
accurate?
still be, you can argue that's still an agent, but then the finance team will take those results and scrutinize and make sure they're correct. But
Yeah,
an agent prepared the initial version.
exactly. So it still needs review.
Yeah.
Yeah, right,
So
right.
the reason I bring up agents is do agents change anything from your perspective in terms of eval, observability, and anything else?
They do a little bit like compared to not determine but to agentic workflows compared to agentic workflows that are not full agents. The only change that really happens, and we are talking now about multi-agent systems, right? So where multiple agents can be chained or looped together. So really, the only difference there is that the length of the trace is not deterministic, and the amount of spans is not deterministic. So in sense of observability itself, the difference is minimal, as long as those agents and multi-agent systems are running in a single runtime. Now, when it comes to evals and evaluation, it is different because you evaluate different aspects of the system. You try to discover different patterns of failures. As an example, if you're just running your agentic workflow, then you know what kind of paths can be taken, and then you can almost 100% assure that the entire path from initial intent to the final answer is completed. Now, with agentic agent systems and multi-agent systems, you can still achieve, let's say, input output, but then what happens in the middle is not a black box, but it is very uh, non-deterministic, right? So your agents can start looping the same questions between each other. So you need to also um, look for failure signals that are not present in agentic workflows, like too many back and forths between the agents, right? Which wouldn't happen in a regular agentic workflow. Also,
Yeah, yeah.
with the tool use, and planning, you need to figure out if the tools are being executed in correct order and similar things.
And that's why I think in that scenario you definitely need to collect fine grained traces, because there's also the communication between the agents, right? So the
Mhm.
one agent might be lying to another agent, so about the status of completion and so on and so forth, right? So you need to really kind of have granular level traces at that point, right? So
I would even say that you always need to have granular level
yeah,
traces, even if
yeah,
you're running a simple RAG
a
system,
single agent, yeah.
you or single RAG system, retrieval augmented generation system. You still need those. granular traces where each of the action is recorded
but
as a thread.
definitely inter-agent communication introduces more points of failure that you really need to make sure that you also
Yes,
uh,
yes,
uh,
for sure,
capture.
100%.
So, so in closing, I guess this is a fast-moving field, right? So there's the challenge for you, the individual, for your professional
Mhm.
development, but then there's also the challenge for you as a AI team in how you keep up. So any tips at both those levels, at the individual level and at the team level, besides going to Swirl AI and taking courses? What other practical tips would you give an individual and a team?
So for individuals, for sure, learn fundamentals. Like don't do not rely on frameworks alone. Understand how everything is really working under the hood. Understand how those systems are actually connected. Just think about how those prompts and context is actually glued together and then passed from an agent to an agent. Do not think that you will be able to just mount a framework right on top of your system, write some few prompts, and everything will magically work. You need to understand how a system works from the first principles. So yeah, so go deep. That's for individual AI practitioners. And when it comes to teams, that's a very good question and a very hard question because in the upcoming 1 or 2 years everything can change so much.
Yeah, yeah,
Mm,
and then one of the challenges, Orimas, for example, in the data engineering space, right? So it
mhm,
used to be several years ago, right? So I have a new data engineer in the team. Then I have them build some basic pipelines. Then they get confident. Then they build more complex pipelines and so on and so forth.
mhm.
And then that's how you get them up to speed and get them more experience. But the challenge now is a lot of those basic pipelines are being can be built with agents, and so a lot of there's some amount of entry level work that used to be the place where you can train
Mhm.
your entry level people. Those are disappearing, which also impacts your talent pipeline, right? So if you don't have people at the beginning, then you won't have experienced people later on. So any tips for teams?
Any tips for
Yeah.
teams?
And
Do not rely.
the challenge of this kind of the pipeline for talent.
Yeah, that's such a hard question.
Yeah.
I would like to say do not dismiss junior engineers and
Oh, I yeah.
try and train
That
them.
I agree completely. I agree completely.
But but that's a hard decision to make, right? Because
Yeah.
because you need to be thinking about the future. Will the future really be
Or
about big teams?
I think Arima's the mindset people have to say, okay, so the traditional training grounds we had in this example of the data engineer were these kind of basic pipelines. Those are gone. Well, then we find some other traditional. We find a different way for them to enter, right?
Hmm. Yeah,
It
that's
might
a
be they
very very
start.
nice
It
idea.
might be they start managing some agents instead of building pipelines from scratch, right? So
We'll see, but we don't know.
yeah, yeah, we don't know. No,
That's the
no, but
hard
I
part.
mean, the agents even in the data engineering space are still human in the loop. So in other
Yeah.
words, a human still needs to monitor and make sure they're working right. So that could be the entry level for junior data engineers, right?
Right, but that's the hard part about this question. The answer is that could be, but we do not know. And for now, does it make probably maybe
No,
it
no,
doesn't
but
make
that
sense.
doesn't. My point is that if you stop hiring these juniors, I
Yeah,
think that's going to hurt you down the road. So you just
what I see a big problem I
hire the
see with
juniors,
juniors.
stick them in a different track, and then, as you say, things might change, but then they can adapt. if you hire the right people, they will be able to adapt, right? So
Agree. But then there are also people who are potentially not right for that role, let's say. And you know, what I
but
currently
that's true.
see
But
with
that's true even when they were when you hired them and you assigned them to build pipelines. Maybe they couldn't do
true,
that. Like, yeah, yeah. So same thing, right? So,
same thing. Maybe what the thing I see with juniors and yeah, less senior people who are currently building is that are relying too much on vibe coding, which is a
mhm.
big problem. Um, so I would also suggest finding some looking for some ways of how to onboard someone new and make sure that the person actually learns the craft and not just go comes in and vibe codes his or her way around, making more issues for senior engineers than actually help. um,
Yeah, that's it. Yeah, this is a big topic, but one of the challenges I'll just say is that the AI tools are getting better at coding at some level because the people building these models are using reinforcement learning, and the signal in reinforcement learning is, does the code run? Yes. Then so then what people are ending up now with this newer generation of these models is they vibe code and they will get code that runs because that's what the reinforcement learning uh, is optimizing for. But that doesn't mean that that code doesn't introduce problems, right?
yes.
But on the face of it, it's running, right? So uh, and so an experienced person obviously can probably handle that. But anyway, so last word, you get the last word, but take us on a positive note.
So I think okay. So I do believe that the future is bright. It's not grim, not dark. I am very excited about what is happening in AI space. I do believe that it will not be as fast. All of this AGI and AI taking over human jobs, it will not happen as fast as everyone is saying. So you shouldn't be worried about that, especially when it comes to enterprises. Like enterprises, like we have, I believe that we already had technology which is so powerful 1 or 1.5 years ago, right? So, and for enterprises to even utilize that kind of technology, which we already had 1.5 years ago, will still take another 5 years or so to fully actually get the most out of it. So, there will be enough work and jobs for at least the upcoming 10 years, and I think people should not be worried too much about it. But in general, eventually, even the ones who will lose their jobs will probably respecialize in that long period of time into some more valuable role. And
And I guess I will close with the following advice, which is basically, I think the main thing that you can do is just keep using these tools and keep learning.
sure,
So
sure.
I think the distinction will be increasingly between those who know how to use these tools well and those who do not. And with that,
100%.
thank you, Aurimas.